This video is to show you how to conduct a simple regression using Excel. Let's review the formulas. For simple regression, the equation is expressed as y hat equal a plus b times x, where b, the slope, equal xp divided by sum of square of x. The y-intercept a is calculated by y bar minus b times x bar. After you identify the regression line, you will need to do hypothesis test based on the Anova summary table. And with the Anova summary table, you will need to figure out the explained variance versus unexplained variance in y. So using x to predict y, the overlapping part is the sum of square due to regression. It's what we call xxr. It's calculated as r squared times sum of square of y. And the part of the variance of y that's not overlapping with x, this part is called SSE, sum of square due to error. It's calculated by 1 minus r squared times sum of square of y. And then you put all the number into the Anova summary table. First, you have the sum of square of term, sum of square due to regression, sum of square due to error. And then you find out the degree of freedom due to regression. Degree of freedom due to error is n minus 2 here. And then you calculate mean square. Mean square is the same as variance. So mean square due to regression is sum of square due to regression divided by degree of freedom. And mean square due to error is sum of square due to error divided by degree of freedom of error. And then you calculate the f-test is by MSR, mean square due to regression, divided by MSE, mean square due to error. Simple regression, we are using median household income to predict the quality of the school district, which is expressed by the number of standards met in each school district. So we are using X, median household income, to predict Y, number of standard met. So that's why the median household income is in the A column and number of standard met is in the B column. As we talked about before in chapter 11, how to calculate average. So I'm just going to put equal sign, average, and for x, go back to the top, highlight from first value all the way to the last value, and close the parentheses, hit enter. 36.84 is the median household income, $36,840. And if we drag this average across here, 18.77 is the average number of criterion met in this 31 school district. Okay, so let's get busy. X minus x bar. Okay, equal sign x minus x bar is all the way at the bottom, 3684. And to allow the copy and paste, we have to put a $sign there, so it will fix the value for you. Okay, so here is your x minus x bar. Okay, and copy and paste all the way to to the last value right here. And we need to do y minus y bar. And we can do the same operation, just drag it over. So I have my y minus y bar. Okay, the third column here is to calculate your xp. So all we need to do is the first value, x minus times the first value of y minus y bar, and hit enter. Okay, and you can drag it all the way down to the last value. Right here is the last value. Okay, so it has a lot of places after the decimal. We can decrease that by, here is the sign how you decrease the decimal places. We can keep it 2 places after. Okay, and the column F here is your sum of square of x, so you need to do x minus x bar square. Here's x minus x bar, square that, hit enter. Okay, and again do copy and paste all the way down right here. The reason you see this dollar sign just means it has too many places after the decimal, and you can okay, that's highlight the entire column. So whenever the changes we're making to all the number. Minimize. Okay, so we are decreasing the number of number of places after the decimal point, and just to make it consistent, we keep it as 2 places after the decimal. Okay, next one, same thing. Y minus y bar square. Hit enter. That's your number. A lot of places after decimal. Let's see if I did it this way and copy it, whether it will keep the same number of places after decimal. Yeah, it did. Okay, that might be a little easier. Okay, so here are all the numbers you need for the calculation. Okay, so when you do a summation right here, this column at the end will give you the SP. Okay, here's the end, close operation. And if you want to remind yourself, you can label that as XP. And since this is summation, you're going to do summation here. You're going to do summation here. Oh boy, we need a little more room. Okay. Yeah, sometimes you just need a little more room to have all your number there. So this number is actually a sum of square of x. And this number here is sum of square of y. Okay, now let's do a little more calculation. If you remember, we need slope b. Slope b is SP divided by sum of square of x, and hit enter. So 0.6078, and if you decrease the number of places after the decimal, In SPSS, they reported 3 places, so let's keep it at 3 places here too. Intercept is gonna be y bar minus b times x bar. Okay, and keep it 3 places after the decimal, negative 3.619 as the intercept. Now you have the regression line, and you need to do a hypothesis test on the regression line. So as you remember, what we need to calculate r squared. So start with r. R is xp divided by sum square of x times sum square of y. But you have to take a square root out, so it's power 0.5. Okay, so this is r, and when we need to do r squared, this value, power 2. Okay, so r, we usually do 3 places after the decimal. So 727 is the Pearson's r, and r squared is 0.528. And now we need to start putting number in the Anova summary table. First, you need to know sum square. You need to know degree of freedom, and you have to figure out MS, and then it allow you to calculate F. The source of sum square can be from regression, or the source of sum square can be from error, and then you have the total. Okay, so the first one, sum square due to regression, is going to be r squared times sum square of y. Okay, and the error is going to be 1 minus r squared times sum square of y. Make sure you grab the value, not the label. Okay, so that's sum square SSR SSE. Okay, can make it 3 places after the decimal. Degree of freedom 1 for regression. You have 1 predictor. Error is n minus 2. In this case, n is 31. We have 31 school district, so the n minus 2 is 29. Okay, MS is gonna be sum square divided by degree of freedom. So it's the same value. MSE, sum square of E divided by degree of freedom. Okay, now calculated F is MSR divided by MSE. Okay, so let's get this value to 3 places after the decimal. Okay, so the calculated F turned out to be 32.486. That is exactly the same value if you have SPSS and you run through it. So here is all the values. And remember how we do a hypothesis test? Step number 1, you state the pair of hypotheses. And in hypothesis test for simple regression, we only have 1 beta weight for the entire equation. So beta equals 0 or beta not equals 0. And identify the rejection zone. It's going to be determined by 2 degrees of freedom. The first one is degree of freedom associated with the regression. The second one is degree of freedom associated with the error term. in this particular case, our critical value of f, according to 1 degree of freedom for regression and 29 degree of freedom for error, the critical value is going to be 4.18 for f value. And the calculated f we just did in our Anova summary table is 32.486. That is much bigger than the critical value we talk about, 4.18. So the calculated f is absolutely in the rejection zone, so we reject HO. Using the median household income can significantly predict the number of criterion met by the school district. And the slope especially is for 1 unit change in x, the value change in y. And the 1 unit change in x is $1,000. So for every $1,000 change in median household income, the number of criterion met by the school district increased by 0.608. So the wealthier district have higher number of standard met in this particular data set. Hope this is clear. See you next time.